Today you guys are going to look at your Unit 4 review video to help you get ready for your test on next Monday and Tuesday. The first learning target is 4a, being able to identify whether a function is linear or not. Please take a minute, identify whether the following functions are linear or not, and then hit play when you're ready to see the answers on the next slide. So our first function is in a straight line and it is going at a constant rate. So we can see that this graph does represent a linear function. Our second graph does not, however. Although both pieces of the line are straight, it changes directions from increasing to decreasing, so it is not linear. Our third equation down here in the bottom left is not linear because it has an exponent other than 1. It's raised to the second power. And our table in the bottom right does represent a linear function because each time y goes up by 3, x goes up by 2. Even though later on y goes up by 6 and x goes up by 4, we can still reduce that fraction to 3 over 2. Same thing when y goes up by 12 and x goes up by 8. Those fractions still get reduced to 3 over 2, and therefore we have a linear function. If you were to plot the points, you would see that they do make a straight line. Up next is our 4b review. For this, we're looking at the intercepts of a function. So go ahead and pause the video as you answer the following questions, calculating the x and y intercept for the first equation, and then identifying the x-intercept of the second graph and explaining what that means in the context of the situation. Once you're ready to see the answers, hit play to see the next slide. Our x-intercept in this case is 4, 0, because if we solve the equation where we plug in 0 for y, 12 times x must be 48, and 12 times 4 makes 48. Our y-intercept is 6, because if we plug in 0 for x, 8 times y equals 48, and 8 times 6 is what makes that equation true. So we have the point 0, 6. On the bottom half down here, when we're identifying the x-intercept, we can see that along the x-axis it crosses at the point 4, 0, so that is our x-intercept. And in the context of this situation, it means that Josh's car trip took 4 hours. It took him 4 hours to get home. So if you wrote something along those lines, you would be correct. Your next key to review is identifying slope. So go ahead and take a minute, pause the video, identify the slope first from the table, then identify a second slope from a graph, and third, identify or calculate the slope between the following 2 points. When you're ready to see the answers, hit play to move on to the next slide. In our first table here, we can see that as x goes up by 2 or 3, when y goes up by 3, x goes up by 2 each time. So we have a slope of 3 over 2. In our graph, if we look at our first point here, we can see we have to go up 1, 2, 3, 4, 5 over 1, 2, 3, 4, and we find our second point. So our slope is 5 over 4. In our third problem, it is y2, 7, minus y1, 10, over x1, 5, minus x2, which is negative 3. Notice how we have 2 negatives on the bottom, which makes a positive. So we have 7 minus 10 over 5 plus 3. 7 minus 10 gives us negative 3. 5 plus 3 gives us 8. So we have a final slope of negative 3 over 8. Up next, we're going to be looking at direct variation. In the first situation, please identify the k value of the following direct variation function. And in the second table, please identify what point needs to fill in our blank spot in the table to make this a direct variation function. Go ahead and pause the video, solve the problems, and hit play to move on to the next slide. Our k value is -9. This number that represents our slope in this situation is our k value. In our table, the point that all direct variation functions go through is 0, 0. Therefore, we have to plug in 0 for this extra y value that we have missing to represent that point. All direct variation functions go through the origin. Our next review is of 4e, of slope-intercept form. I want you to first identify the slope and the y-intercept of this function, and then create a graph of the given function. Go ahead and pause the video as you solve this, and then hit play when you're ready to see the graph on the next slide. Our slope here is -1/3, and our y-intercept is the point 0, 8. So if we look at our graph, we graph the point over 0, up 8, and then we move down 1 to the right 3, down 1 to the right 3, and we can follow that pattern to get more points on our line. After slope-intercept form, we want to look at point-slope form. So you want to identify the point and the slope of your point-slope form equation, and then from that, create a graph of that equation. Pause the video while you solve this, and then hit play when you're ready to see the next slide. Our point in this case is 3, 4. 3 is our x-coordinate, 4 is our y-coordinate. Now remember that our x and y have to switch signs to move from the equation to the table, or to the point. If they're positive in the equation, they're negative in the point. If they're negative in the equation, they're positive in the point. Our slope is the number in front of our set of parentheses, so our slope is 2. When we graph this, we go to graph the point over 3, up 4, and then we use our slope up 2 over 1, up 2 over 1, up 2 over 1 to get more points along our line. Second to last is standard form of a linear equation. Please calculate the x and y intercept, and then create your graph of the function. In this case, our x-intercept is 6, 0, because 4 times 6 makes 24, and our y-intercept is 0, 8. If we plug in 0 for x, 3 times 8 makes 24, and we have our correct y-intercept. If we graph those points over 0, up 8, over 6, up 0, connect our line, we have correctly graphed our function. Our last review for this video is on converting between forms of linear equations. In both situations, please convert the equation to slope-intercept form. Go ahead and pause the video as you do this, and hit play when you're ready to see the answer. In the first equation, we have to distribute 1/2 to both pieces in parentheses. So 1/2 times x gives us 1/2 x, and 1/2 times 8 makes 4, because half of 8 is 4. So we have the equation y minus 2 equals 1/2 x plus 4. Now we add 2 to both sides to get our slope-intercept equation of y equals 1/2 x plus 6. In our second equation, the first thing we need to do is add 2x to both sides, because it's being subtracted here. So we add 2x, we get 5y equals 2x plus 15, and our last step is to divide each piece of the equation by 5. When we divide by 5 in each spot, the 5's cancel, we get y, we have 2/5 x, 2/5 is our slope, and 15 divided by 5 makes 3. So we have y equals mx plus b, our equation in slope-intercept form. Make sure you guys have this in your notes so you can use it on the test on Monday. Good luck!